Reduced row echelon form. One more time. What does it look like? Well, first of all, hold on, wait. We have a system of equations. We don't even have a matrix yet. How do we get one?
1, 2, 7.
1, 2, 7.
2, 1, 8.
Right over here.
Dots.
Separating the variable coefficients from the constants. Having the x's in one column, the y's in another. If it was ever out of order, switch it around to get it to be this order. RREF says I want a leading diagonal, or a diagonal main diagonal of 1s. But what else?
0.
Okay. Yesterday, what was the system? We work how? By rows or by columns?
Columns.
We work by columns. Every time we are working with a column, what do we establish first?
The 1.
The 1. The nice thing for us, isn't this 1 already established?
Yeah.
Okay. So once the 1 is established, you guys tell me, what do we do next?
-2.
Okay, that's what we do. Why do we do it? What's our goal? What are we trying to accomplish? To get zeros in the rest of the column. Those of you that didn't check out the video, slackers. But coming back. Get a leading coefficient of 1, establish the 1, and then we need to get zeros everywhere else. Before we move on to the second column, get the 1, zeros everywhere else, above and below. So, now go ahead. Oops, too far. John, you were trying to explain to me.
Huh?
How do you get a 0 here?
Row 1, -2 row 1, plus row 2.
And technically, if I had room, if I made myself room, I would say, nope. I would say, almost. Struggle. Row 2. I would say into row 2. Okay. The system is, if you ever need to get 1s, and it's not there already, multiply by the reciprocal or divide. And if you ever need to get zeros, multiply the row with the established 1 by the opposite coefficient and then add. Now, kiddos, what did we do to start off class yesterday? I said we need to practice our mental math, because a lot of mental math is going into this process, right? That's very sad. Mental math meaning, when you write down -2, row 1, plus row 2, don't you have to do it to every single element?
Yep.
These bars are good, but they have like this weird liquidy thing on them. Anyway, here we go. So, what's -2 times 1 plus 2?
0.
Wait, pause! Who gets to say the same?
First row.
Okay, -2 times 1 plus 2? -2 times 2? -4. Plus 1? -2 times 7? Plus 8? You guys double checked me, we're good, right?
Yes.
Are we done?
No.
There's the first column then. Yeah. Second column, first step. Establish the 1 in the diagonal. I've already said it today, but someone else explained to me how are we needing to establish that one. Multiply by the reciprocal or divide by the coefficient. And we have to follow the system, otherwise we'll mess up the 0 that we need to stay there. When we multiply everything by -1/3, the first row once again is staying the same. We end up with 0 times anything is 0. -1/3 times -3 is 1. Exactly what we wanted. It's established. -6 divided by -3 or times -1/3 is +2. Good. I'm almost there. Now that the 1 is established, what do I do to finish the column?
-2 or 2.
Multiply the established 1 row, which is row 2, by the opposite coefficient, add to the row that you need it to get into. Now the second row will stay the same. 0, 1, 2. The first row will change. Following the system, you'll be fine keeping that 1 as a 1, because -2 times 0, anything times 0 will be 0. plus 1 will be 1. You're going to keep the 1 and the zeros exactly as you need. But negative 2 times 1 is negative 2, plus 2 is negative 2 times 2 is negative 4, plus 7 is. Anybody beat me and agree?
Yeah.
Anybody solve it another way to check?
Wait.
Ooh, how come? Good. Negative 4 plus 7. Positive 3. Now double checking, we're good? Could you have done substitution elimination? Yes. What was I trying to have you do? Practice the system that did all of this work in a much easier, simpler way. So maybe on a test where, or the test where the calculator is not allowed, I might have you in the direction solving this a certain way, even though you could check it with another way. Just make sure your work lines up. At the end of the day, what's my solution? Done. Now, that reminded me really quickly. Yesterday, kiddos that were here, what did I do? Here's a stack of test corrections. Just go ahead and take the pile, pass it around the room. If you need one, take one. If you don't need one, pass it on. Before class is over, I will pass out to juniors your guys' tests as well. Those corrections are going to be due on Monday. Those corrections are going to be due on maybe Tuesday. I think the homeworks will be due on Monday first. Although you're grading 8-1 tomorrow. Well, then pause. Anybody in AP Chem and AP Bio, I need you to think of, you missed yesterday. Did you do what you were supposed to watch the video? Just answer to yourself, not to me. Did you do what you're supposed to do, and are you ready for today's class? If you're not, be like, ooh, I better do better on Monday. Because everything that I need will be on the website ready to go as it was last night. Okay, so here we go. That one's done. Let's keep going though. What's going on here? What's wrong?
Why is it so big? Wait, can you divide that by 4?
You can divide everything by 4 if you really want to. Because we're human, not computers. But the problem is, does that help anything? Here's the dilemma, cool kids. It says using what? If you plug that into a calculator, it would be a 3 by 3, right? Your calculator is going to be totally confused because as soon as you go to a third row, it's like Z, and you're like, how could you make this something that the calculator would understand? What matrix would you form? Negative 1, 1.
0.
And then 3, 4. And then 4, negative 8. You can make it into a matrix that we can actually work with using our RREF. The problem is we have to put in zeros for all of our Z's because they are not in there. And if you try to do RREF to the matrix to say to check with your calculator, it wouldn't understand if you just put in 3 equations with 2 variables. It doesn't make sense to it unless you allow for the Z column. Unless you allow for the Z column. Now kiddos, go ahead and put this in your calculator. We talked about how to use our calculator. For those of you guys that weren't here yesterday, hopefully you looked at the video, but if not, you already saw last chapter how to put a matrix in. So, calculator on, if you don't have one, hopefully someone in your group does. Go to second, x to the negative 1. Make it a 3 by 4 with the third column being zeros. And I want you to try to do RREF to the matrix. We're looking ahead and seeing what happens.
Wouldn't that be x minus 2y?
Oh, thank you. I just wasn't even paying attention because it wasn't going to be helpful. But yes, it would be x minus 2y.
Oh.
Good job. Equals 8, right?
Yeah.
Good job, good job. Fine.
Wouldn't it be helpful though, because then you could switch the third matrix or the third row with the second row, and then
You could do the row swap, that's true, and you could do like an elimination with it if we were doing the by hand row echelon method where we were following step by step, but this technically says matrices. And so as far as matrices go, an RREF with ones down the main diagonal and zeros above and below, I'm not exactly sure swapping these two makes a big difference. Because even if I swap this guy, the second one with the third one, there's still not a 1 in the correct place. So, I mean, it might be nicer in some ways, but in some ways it's not going to really make a big difference. Okay, you guys are putting this in your second x to the negative 1 matrix edit, right?
Yep.
Putting in your coefficients, trying to do RREF. That's an enter, that's an enter. Problem is my keyboard doesn't let me do negative numbers very easily. We have 3, we have 4, we have 0, we have 4, we have 4, we have negative 8, we have 0, we have 32. Okay, how'd you guys do RREF again, just to remind poor juniors that might have not gotten it yesterday? Second, matrix, math. Letter B?
Yeah.
And then I go ahead and do second, matrix, go get matrix A. Well, I don't, if we tried to do RREF using all of our row operations, multiplying this guy by a negative 1, then multiplying row 1 once we established by negative 3 and adding negative 4 and adding, we would do the whole process of yesterday. We would end up with the following. You guys saw it, right?
Yeah.
1, 1, 0, 1.
that doesn't seem right.
It doesn't seem right. Help out. What's going on in the matrix? What's the first column representing? X terms. Second row, second column, Y terms. Third row, third column, Z terms. And then we have our constants, right? So literally, doesn't the 1 in this spot correspond to 1x equals 0? And the second one, doesn't it say 1y equals 0? And the third one says 0 equals 1? It's false. So our guess right now would be no solutions. Kiddos, what's another way that you could have come to the no solutions conclusion? Let's check it and see if it's actually right. That says that no solutions. That's no solutions. Couldn't we have taken the first two, like our system would say, right? And couldn't we have done elimination? And even Ryan was saying, well, you know what, if you divide everything by 4, these two would be really nice to put together. That's totally true. We could do that too, but just doing the system. I would multiply this guy by 3, right? Mm-hmm. So multiplying by 3, I would get, multiplying by 3, 7y, multiplying by 3, negative 66, negative 62. So that I would end up with y is equal to, that was 6, no, that was 7. And then negative 62. So negative 62 sevenths. I would get my y to be negative 62 sevenths. Then, kiddos, wouldn't we also do the next two? Now the next two, I'm going to go ahead and look at this guy because he's easier multiplying by, let's multiply by 2 so the y's cancel. I want to compare. Let's multiply by negative 3 so the x's cancel. So negative 3, 3x minus 3x would cancel. Negative 3, 6y plus 4y would be 10y. Negative 3, negative 24 plus 4 would be negative 20. Negative 20 over 10, y equals negative 2. What's the dilemma? The solutions don't match. If the solutions don't match, could either one be the same solution for everything? No. So what's going on? Does this guy intersect with that guy? Yes. Does that guy intersect with that guy? Yes. At the same point? No. So is there something shared for everybody? And the answer is no. False statement, no solutions, good. How about number 80? What do you guys think we can do to make that guy into a matrix? Let me make him a little bit bigger again. How can we make this guy into a matrix? Okay, Patricia, what'd you say? Let Z equal A? Ooh, interesting. What's she remembering? Remember REF from last chapter? What if we only had 2 equations with 3? What will we do down here? We could do that in our calculator. Some of you guys might want to run it in your calculator and say, hey, I'm using my calculator to double check things. The calculator will go through the same exact steps that we did in the sense of by hand yesterday. And what would it end up getting? You guys can do that. I don't mind. Get it in there, run it. Do REF. I'll do it too. Patricia said, let Z equals A. And guys, in section 7.3, we did something like this where we had 2 equations with 3 variables. We didn't have enough. And we said, wait, but we can still say the answer is just going to have A's in it. But let's see what looks or what happens when we're just doing REF, not thinking about whether it's working or not working. How this would show up as weird. And what would happen if we did still try to REF it, with the last row all being 0. Wait, REF? Why didn't it get it into REF? The calculator is saying that is REF. What's wrong? Read off the coefficients. What did you guys get? Negative what? Then?
9, 1.
It got as far as it could. Whenever you're given just 2 equations, or whenever the very last one cancels out to zeros, the first column established the 1 zeros, zeros everywhere else. The second column established the 1 zeros everywhere else. The third column established the 1 is impossible. So it says, okay, I'm done. That's the best I can do. That's REF. There is no established 1, so I can't make those zeros based on the system. So we're stuck. But even though the calculator is stuck, and it can't go all the way to get me the solution, if we remember, either if you're given 2 equations only with 3 variables, or when this guy randomly cancels out as you're doing your work, and it's impossible to get Z, you have to remember that action step from, once again, section 7.3, if you want to go back and look in notes and or the video. We let Z equal A. But Z is not a constant, we say, okay, but he can be some constant, just we don't know 1 constant, it's infinitely many. So then, guys, how would I actually solve this? Because we're not done. Calculator can't get me there. Substitute. So I take my equation of 1y plus 9 times Z equals 1. What am I plugging in for Z? A. So therefore, y is equal to 1 minus 9a. I have y. I have z. What's left to solve for? X plus 0. Well, 0y is just 0, right? Minus 5 times plug in a. So what's x equal? Got it. So is this one going to be an answer, like a numeric 1 answer? No. It's going to be an infinitely many answer where whatever z could be would determine what y could be and what x could be. The calculator gives you enough, but you have to first of all figure out what's going on. Say, uh-oh, z can be anybody. Okay, fine, if z can be anybody, then let's plug them in to get y and get x, and that's my final solution. Janelle, what's up here?
So we didn't set Z equal to A for the previous equation that
because it was false. Oh, before? Oh, there's no z. So that means like everything lines up in the sense of two unknowns, two equations. My identity matrix is possible. Yeah. So two equations isn't a problem unless we really need three. Does that make sense to you? In your notes, kiddos, I'm just going to show you that it's here. I've gone ahead and like stolen, quite literally, I just copy and pasted a few different things from what I could give you a handout on how to do matrices on the graphing calculator. If you think about your RREF and doing it by hand, it can be quite annoying, especially if you can't find your mistake. So like, for instance, if you were an accountant and you were going through balancing, yes, it's balancing, balancing your records. There tend to be check figures along the way, especially if you're in an accounting class, like check figures to make sure, okay, after all this work, have you gotten it? Okay, good, keep going. That's kind of what you could do in your calculator with this whole RREF thing. You could check certain steps of what you're doing, and not just like looking at it, but if you couldn't find your mistake, actually the graphing calculator can do a lot. For instance, this is just how to put it in. We already know how to put it in, that's no big deal. But you can actually do things like row swap. You can actually change one row to another. You can do row operations with your calculator. There's this whole menu where you can actually do things like, hey, I want to multiply, where is it? Yeah, multiply a row and then add it to. You can do like what we were doing with the idea of, here we go, taking row 1, multiplying it by -2, adding it to row 2, and then storing it in row 2. You could actually do each of the steps that you thought was necessary and check whether or not your in-between steps were right. I'm not sure if it's super helpful because it kind of makes you work really hard to check when maybe you could catch the mistake or catch your error by just going through and doing the math again. But anyway, it is there. It is interesting. Some of you guys, if you do your matrix math and as you look down past the REF and the RREF, you'll find some of these different operations that you could do to check it along the way. And that's kind of what you would have to use in order for the programming. Like, how did the RREF program get made? What was it doing? Well, it's basically doing these row operations, but in a very particular order where no matter what numbers are in each of the different places, if you go through step by step by step, this and this and this with each of the rows, multiplying and adding, etc., you could get it to be in RREF form. Anyway, just kind of giving you a peek behind the scenes as to what's going on. But for this one, that's just explaining the difference of the two. And we know the difference of the two. In the sense of REF would take this matrix that is a Z equals A matrix and just make leading coefficients of 1, zeros below, wouldn't even mess with the tops. If you did do RREF, because this bottom row, once again, either cancels out or was never there, it's not going to be able to look all nice and pretty with all the 1s and zeros elsewhere. But our REF would have gone a step further, to not just to get the leading coefficients of 1s and zeros below, but it would also get zeros above. And if possible, it would finish off that one and get zeros also. But just kind of showing you the difference in what the calculator does and what it's trying to show you. Let's go ahead and end off section 8.1 with this final example. Is he one of the really nasty ones just from looking at it? No. I mean, he's missing stuff, sure. Like he's missing an X in that one, missing a Z in that one. Like he's missing stuff. But he's not super, super nasty, right? Where would we start? Putting him into matrix, right? Some of you guys might want to swap something. I'm not really sure it's going to be that helpful to swap anything. Bless you. Doesn't look super helpful. We're not going to be able to finish the entire thing. I just want to see if you guys know how to start. If you were solving this by hand, what would you do first? Yeah, get a 1 right there, right? Get a 1 by multiplying by the reciprocal, right? So I would go ahead and, if you guys don't mind, 2 divided by 2 is a 1. Divide by 2, divide by 2. What's 24 divided by 2? So let's check, what would you guys do next? Oh, hey, there's already a 0. Go team. But what about this guy?
-7.
I need to get rid of him, so I need to do the opposite, -7 times the 1 that's there. So -7, the 1 is in row 1, plus row 3 into row 3. And as soon as we get the 1, 0, 0, nice thing is these rows have to stay the same. Remember, what you do to one term, what do you got to do to everybody? The same operation. So in order to keep going, we need to go ahead and do this row operation right here with every single term. Finish off this row, and then that first column is done. Then who do we go looking at? Make him a 1. Once we make him a 1, what are we going to aim for? Making zeros. Then keep moving, make him a 1, make zeros. Do we at least get the system down? 8.1, due tomorrow. In order to grade, but we're going to go ahead and start 8.2 because you guys might be like, oh man, that was just the first section, we should sue. Well, maybe not sue. Section 8.2, you would think it gets harder, but to be honest, it actually starts off getting easier. It reminds us that we have these little names for every entry. And it gives us the idea of same order and same corresponding entries. Guys, go ahead and put down your pencil for a second. You won't have time to copy anyway. Go look on the video tonight if you need to get it in there. I'll explain why in a second. But what I want to show you is if 2 matrices are equal, guess what's going to be true about corresponding terms?
That's not that bad.
It's not that bad. Wouldn't it just be only the equations?
Yeah.
Right? Okay, that's not bad. Hold on. Okay, the section's going to get way worse.
Oh.
Oh. How are we going to add matrices or subtract them? Add the corresponding ones, which was possible here. Wait. Here we go. It's only possible to add and subtract when they match up. Guess what we're going to do when we need to multiply? Distribute to every single piece. Here, this is where notes pick up tomorrow in the video. Maybe. Need to get these 3 pages down really quickly before you come in tomorrow. Sound good? Okay, play with A1 tonight. Do these pages in your notes. That way you can pick up where the video picks up tomorrow. Bye, guys.